Hello world, it's Angelot, and I'd like to share with you a project I've been working on called Tributary. So, Tributary is inspired by the awesome Brett Victor video, Inventing on Principle. So, if you haven't seen that video, go, YouTube it, search for it real quick, pause me, watch that, come back here. Everything here will make a lot more sense, and I think you hopefully will be as inspired as I was. So here what we're doing is we have code in a code editor that is evaluated and it draws into this window here. So these colorful lines are being drawn by some JavaScript, mostly powered by D3. And what we can do, similar to one of the features of Brett Victor's video, is play with the parameters interactively. So this code is being reevaluated with the new values of each of these parameters. If we come, change the stroke width, we get different effects. We can change the opacity, make it more see-through, change the pattern of the waves, move them around. Really explore what this code can do if you try different numbers. Now I'll show you a couple more examples. Here is an optical illusion which I wrote in D3 basically by looking at a picture of this optical illusion I found online and just guessing, seeing, oh, like each of those squares looks like it's rotated just a little bit more than the last one, and I wrote some code to try to figure it out, and I eventually think I figured out how to get the illusion. And it turned out that it's all based on a few of these parameters, and getting these right is how you get the illusion right, and changing any one of them can destroy the illusion or give you new and different interesting patterns. And just the rotating itself is interesting. We can change the number of squares there are used, the radius. We can even come in here and make more rings. Change, let's see, what else can we change? The width of each square. Let's make it wider, bigger. And pretty soon we get far away from what we originally had. And we get some pretty interesting things, right? And actually, all of these here, these few here, are based off that same code with different parameters. You can get to here from that last image. I mean, these colors, and you can blow out the radius. Or you can use other SVG techniques, like this one uses a use element to have a little icon that I got from the noun project, and you rotate this guy around, get some cool patterns. So I use this to play around and explore, but also for rapid prototyping. So if I want to try some algorithm, like get this effect, or draw a bunch of lines that are based on data, I want to write the code, but I find using one of these online code editors, while this is CodeMirror, it's really slick, I still want to use Vim, for instance, or for the sake of this demo, I want to use TextMate. So I'm going to open this with TextMate, and I'll make that circle not be so huge. I'm going to save this, and it's going to change. So you can edit all you want in TextMate, and every time you save the file, this is watching, and we just dragged and dropped it into the window. That's all that happened. And this is nice because a lot of times I find myself, if I'm writing functions, I want to think in my usual space, right, my usual editor. And then when I get to parameters, then it's nice to be able to say, oh, what happens if I move this around a little bit, or I want to tweak this, make it a little wider, go back there. This kind of thing is nice to do interactively, but for now, until someone can port this into Vim or TextMate, we can work in both environments. And also, I believe this is a good way that we can demonstrate, D3 code. So this is also inspired greatly by Blocks, Mike Bostock's project, where you can use GitHub gists to share code and it evaluates them. So this is doing the same thing up here. It's grabbing this JavaScript file out of this GitHub gist, and this is a simple D3 bar chart, and you can see, if you change the data, it rescales based on the min and max. So, and this final example is actually something that excites me a lot. Here we implemented a couple numerical integration methods, and so this is applied math stuff that you might get in college if you're in the computer science or applied math areas or anything like that. And when I took it, I took differential equations. None of that stuff really clicked for me in undergrad, and in my grad program, I started writing stuff where I would plot what came out on the screen and seeing things interactively, and that's when a lot of this stuff started making sense. So what I did with a couple of my colleagues was rewrite the numerical integration schemes in JavaScript, which is something you don't normally do, right? JavaScript high performance. I mean, things are changing, but not that fast. But you can still show a nice demo of those techniques. And what this shows here is this red line is the solution. So this is a sine function. This is some pattern that we want to approximate with a math function. And there's several techniques for doing that. And the most basic one is called the Euler Method. And this blue line here represents that approximation. And you can see how it's not right, and it's not a very good approximation. Now this green line here is much better. It's actually, staying on the line, but it's, still pretty jagged and not really that great. But it's better than the blue line. And what these methods essentially depend on is the number of points you use to make your guesses, and the more points you use, the longer this algorithm is going to take, but you can see the better the approximations. But now we increased our points here a lot, and the blue line's a lot closer, but see how the green line was that much better many points ago? So even here, the green line is better at this 15, and at 45 or 60 even, the blue line's not even better than that green line was. So anyway, you can see by changing the number of points, the actual implications of choosing these different methods, something that is normally a very abstract lesson taught from a math textbook. And I'm personally going to try to do more of these things for the math techniques that I learned in school, and hope other people enjoy it or can learn from it. And here, I mean, this is just the sine function, or this is the original differential equation, and you can play with these numbers yourself right here. So I'm hoping that others will write code snippets, share them. I didn't show it, but let me do that really quick. It's really easy if I, let's say, change the amplitude of this a lot, make these much bigger, change the lower the opacity, and say, oh, okay, I want to share this. I can fork it here, and this just made a copy of it, and now I can actually open this link in a new tab, and it's the same thing that we just saw. So you can share that with people, or you can tweet to tweet button. And I hope people can use it to learn D3. I know a lot of people are trying to do that right now, and I'm excited to see what people come up with. So yeah, thanks, and please let me know when you make a cool cool thing to share. Thanks.